Welcome. Today we're going to use the binomial theorem to expand negative powers. Recall the binomial theorem. The binomial theorem states that a plus b raised to some power n is equal to a raised to the maximum power, which is n, plus n multiplied by a n minus 1. Notice the n there starts reducing in power by 1 as the b starts increasing in power by 1. Okay, then when we go to the third term, we've got n minus 1, this n and that n there, and then in brackets we multiply it with n reduced by 1 divided by 2 factorial. The power on a here reduces by another 1, so it becomes n minus 2, and the power b increases by 1, so it becomes from 1 to 2, like that, and so on and so forth. Suppose we want to expand x plus y raised to the power 3. What would we do? Okay, so all that we're going to do is we're simply going to substitute the value of n. So wherever there is n, here in the place of n we've got what? Negative 3, and in the place of a we have x, and in the place of b we've got y. So we're going to substitute these values into the binomial theorem. So here we're going to have x raised to the power minus 3, which is that one. Then n is negative 3, so we're going to have negative 3. A is x. N is negative 3, negative 1, so we have negative 3, negative 1 there, and our b is y raised to the power 1, and so on and so forth. So we've got negative 3, negative 3, negative 1, which is that one, divided by 2 factorial. A is x, n is minus 3, so we're going to have x minus 3 minus 2, y is b, and so on and so forth. Okay, then we will start to simplify that. So according to laws of indices, anything raised to a power a negative can be written as its reciprocal raised to a positive power. So I have reciprocated that one and changed the power to a positive. Instead of negative 3, we've got positive 3. Okay, here we've got x minus 3, x minus 1, so it makes minus 4, and if I reciprocate it, it becomes positive 4. Okay, and that minus 3 is that one there. The y to power 1 is that one there. Okay, so we've got negative 3, negative 3, negative 1, which is the whole lot of that, divided by 2 factorial, which is that one. This one becomes negative 5. Negative 3, negative 2 is negative 5. If I reciprocate it, I get positive 5. And we've got y raised to the power 2 there. Okay, the same thing here. We're going to have negative 6. If we reciprocate it, it will become positive 6. Okay, so we continue simplifying. 1 over x3 remains the same. Notice the power, the sign there has changed to negative because positive multiplied by negative is negative. Okay, and then we've got y raised to the power 1 according to laws of indices, it's just the same as y, so we've got y over x4. This is where we're getting that from. Okay, this is negative 3, that's negative 4. If I multiply negative 3 and negative 4, I get positive 12. This is where positive 12 is coming from. 2 factorial is simply 2, and then we've got y raised to the power 2, which is that one, and x raised to the power 5 is that one. Here we've got negative 3 multiplied by negative 4 multiplied by negative 5, which gives us negative 60, and 3 factorial is simply 6. Our y raised to power 3 is that one there. X raised to power 6 is that one there. Okay, so next what we're going to do is simply reduce these fractions, simplify them to their lowest. Okay, so here we are. If we divide 12 divided by 2, simply get 6, and 60 divided by 6 is 10. So here is our series. If we expand x plus y raised to power negative 3, this is what we get. And this is an interesting series because it's making a pattern. Look at the denominators. The powers on the denominators are simply increasing by 1. We've got 3, 4, 5, 6. And so we can even guess what the next one will be. Obviously, it's going to be x raised to power 7. Okay. And then we've got here, we're seeing a pattern as well. We're changing from negative to positive to negative to positive. Okay. And then y here as well. We've got y to the power 1, then becomes 2, then 3. And obviously, we can guess what the next term will be. To be raised to the power y to the power 4. What about the numbers on the denominator? They also make an interesting series. What I'm seeing here is that if I add 2 here, I get 3. And then from 2, I increase by 1 to give me 3. So 3 plus 3 will give me what? 6. Then 3, I add another 1 to give me 4. So 6 plus 4 will give me what? 10. So I can easily guess what that will be. Okay, it's obviously going to be 4 plus 1, which will be what? 5. So 5 plus 10 will give me 15. So the term which is supposed to be here will be positive 15 y to the power 4 divided by x to the power 7, and so on and so forth. This is how simply we expand binomial expressions which are raised to a negative power. Please try out the following exercises. All these have been raised to negative powers. I forgot to tell you one thing, just one more thing. Notice that when we raise to a negative power, the powers here are increasing, so they're not going to terminate. They'll simply just be going on and on and on and on and on. Y will be moving from 1 to 2 to 3 to 4 to 5 to 6 to 7 and so on and so forth and so on and to infinity. The same here for x. X is 3, 4, 5, 6, 7, 8, 9, 10 and so on into infinity. So the best thing that we can do here is we're not going to write down as many terms as possible, as we can see that our terms simply go into infinity. What we're going to do here instead is that we're going to terminate our series, and the best place to terminate our series is when we've written down at least 3 terms, maximum 4 terms. Please don't go ahead and write 5 terms and 6 terms unless you have been advised to do so. Okay, so please go ahead and do this exercise. In this exercise, just expand up to the 3rd term. Okay, so expand these binomial expressions raised to negative powers all the way up to the 3rd term only. Okay, if you got problems, you can reference John Bird Engineering Mathematics 6th edition. Thank you.